Hello, and thank you for tuning in to Eureka Module 6, Lesson 8. Today, our learning target is I can generate a number pattern from a given rule and plot the points. So today, we're going to be looking at some rules for X and Y, and we're going to see if we can create some coordinates based on those rules, and then we're going to plot those lines on a coordinate plane. What you need for today is the lesson 8 template, which you should have in front of you. For problem number 1, we are not going to be using it and just answering some questions on Edpuzzle. And for problem 2, we will be using the template. So please make sure that you have it in front of you, and we will be collecting it tomorrow. So question 1. Right now, we're just going to go ahead and look at some rules, and we're going to see if we can come up with a couple of sets of coordinates that meet those rules. So, for example, rule A is y is equal to x. So if I'm creating some rules based on, if I'm creating some coordinates based on those rules, then I can choose any x, and then I can just choose a y to match it. So for rule A, where it says y is equal to x, if I choose x is 1, then y has to be 1. If I choose x is going to be 3.5, then y is going to be 3.5. It doesn't matter what my x is. I can choose any number. My y has to match it. For rule B, it says y is 1 more than x. So if my rule is y is 1 more than x, if I choose 1, y needs to be 1 more than that, so y is going to be 2. If I choose 5, then y needs to be 1 more than that, so it's going to be 6. If I choose 10.5, then y needs to be 1 more than that, which is 11.5. For rule C, it says y is 5 times x. So for C, if I choose x is going to be 1, then y needs to be 5 times as much. So y is going to be 5. If I choose x equals 7, then y needs to be 3 times that, which is 21. If I choose x equals 10, then y needs to be 3 times that, which is 30. I can even do decimals or fractions. So if I choose that x equals 2.5, well, 2.5 times 5, let's see. Oh, sorry, I was in times 3 mode. This should be 35, and that should be 50. Sorry about that. If I do times 5, well, 2 times 5 is 10, and 1.5 times 5 is 2.5, so it would be 12.5. Pardon the error. I was actually looking at 3 times. Okay, so for rule D, it would be y is 1 more than 3 times x. So for rule D, if I choose 1, I want to find what is 1 more than 3 times that number. So I'm going to do 3 times x, which is 3. And I'm going to find 1 more than that. So it's going to be 4. When x equals 2, I would find 3 times that, which is 6. And then add 1, it would be 7. If I chose x equals 10, it would be 3 times that, which is 30. Plus 1 more is 31. We're going to pause here, and we're going to move on to the next question. So if you have the paper in front of you, please make sure that you have it out while we take a look at our template. Mine looks a little bit different from yours just to make sure that it fits, but it's all the same. So problem 2 is create coordinate pairs from rules and plot the points. So we have a rule here, y is 2 more than x, and we're going to plot some points, and we're going to put it on our coordinate plane. So the rule says that y is 2 more than x. So I can see that our x axis goes up to 14, and our y-axis also goes up to 14. I want to make sure that neither one of my coordinates end up beyond here. Even though they do exist, I can't plot them because my graph isn't big enough. So I'm going to choose a simple number like 1. So if I choose a number like 1, if I choose x is 1 and y is 2 more than that, y is going to be 3. So my coordinates would be 1, 3. Please follow along and write these coordinates down. If I choose x is 3, then y is going to be 2 more than that, so y is going to be 5. If I choose x equals 6, then y is going to be 2 more than that, so 8. So I have 3 points for line A that I will plot now. 1, 3, 3, 5, and 6, 8. And I'm going to try to connect these as straight as I possibly can. And remember, even if I didn't plot points, it does go on forever in the same pattern. And so this is line A. Let's take a look at line B. Line B says y is 2 times x. So if I choose x is 1, if I choose x is 1, okay. There we go. If I choose x, I know it's not showing up. Okay. If I choose x is 1, then y is going to be 2 times that, so it's going to be 2. So it's going to be 1, 2. If I choose x is 5, then y is going to be 10. So it's 5, 10. If I choose x is, let's choose 7, because that'll take us to the top of our graph, 7, 14. Then I can plot all 3 of these, 1, 2, 5, 10, and 7, 14. And I'm going to try to plot these in a straight line as well as I can. And that's line B. Let's take a look at line C. So the rule for C is y is 1 more than x doubled. So I'm going to double x and then add 1. So if x is 1, then y is going to be doubled and then add 1, so 3. If x is 3, let's double it and get 6 and then add 1 more and we'll get 7. So we have 1, 3, 3, 7. And if x is 5, it's times 2 is 10 plus 1 is 11. So 5, 11. 1, 3. I'm noticing that they have the same coordinates. 1, 3, 3, 7. And 5, 11. And I'm going to try my best to connect these in a straight line. And that's it. Your paper should look somewhat like mine, with your 3 lines A, B, and C. So I'm also noticing now that some of these lines intersect. I notice that A intersects with B and A intersects with C. I'm wondering why this point here follows 2 rules. And so I'm seeing that line C intersects at 1, 3 and with A, and I can see that here because they both follow the rule that y is 2 more than x here, 1, 3, and then 1, 3 also follows the rule that y is 1 more than x doubled. So there are points that can follow 2 different rules, and that is going to be end up being very common. And you can visually see if a point follows 2 rules if 2 lines cross at the same point. Thank you very much for tuning in, and I'm looking forward to seeing you in lesson 6.9.